Candocuronium iodide, formerly chandonium, HS310, is an aminosteroid neuromuscular blocking drug or skeletal muscle relaxant in the category of non-depolarizing neuromuscular blocking drugs. Its potential adjunctive use in anesthesia to facilitate endotracheal intubation and to provide skeletal muscle relaxation during surgery or mechanical ventilation was briefly evaluated in clinical studies in India, but further development discontinued because of attendant cardiovascular effects, primarily tachycardia that was no worse than but also not an improvement over the clinically established pancuronium bromide. Candocuronium demonstrated a short duration and a rapid onset of action, with little or no ganglion blocking activity, and it was only slightly less potent than pancuronium. Background. As with other neuromuscular blocking agents, candocuronium preferentially antagonizes competitively the nicotinic subtype of acetylcholine receptors. The agent was developed by the laboratory of Harkishan Singh, Punjab University, Chandigarh, India, as part of the search for a non-depolarizing replacement for the most popular clinically used depolarizing agent, succinylmethonium succinylcholine. Design of candocuronium. The mono- and bis-quaternary azosteroid series of compounds to which candocuronium belongs are based on the same principle that led to aminosteroids such as pancuronium, vecuronium and rocuronium, use of the steroid skeleton to provide a somewhat rigid distance between the two quaternary ammonium centers, with appendages incorporating fragments of choline or acetylcholine. The discovery program initiated by Singh initially led to the synthesis of the bis-quaternary non-depolarizing agent HS342, 4,17-A-dimethyl 4,17-A-diazo-D-homo-5-alpha-androstane dimethiodide, that was equipotent with tubocurarine and with one-third its duration of action, but not suitable for further clinical evaluation. Modifications of the HS342 structure led to two other notable agents, HS347 and HS310, subsequently named chandonium, then candocuronium. HS347 was equipotent with tubocurarine but exhibited considerable ganglion blocking activity. Candocuronium appeared to be suitably placed for clinical trials following encouraging preclinical evaluations. Modifications to the candocuronium design. However, candocuronium did not provide the desired profile, and a further extension of research was undertaken to overcome its limitations. This led to four more promising compounds, HS692, HS693, HS704 and HS705, whose onset and duration were indistinguishable from candocuronium, but, unfortunately, all demonstrated profound vagolytic effects and much weaker potencies than candocuronium. To improve on potency, further modifications of the candocuronium nucleus were undertaken, leading to the identification of yet another promising compound, HS626. Unfortunately, upon further preclinical evaluation in the cat and isolated preparations, HS626 demonstrated a slightly more desirable neuromuscular blocking profile than that of candocuronium, but its overall improvement was insufficient to warrant advancement to clinical testing. Modifications at 3 and 16 positions of androstane nucleus. The discovery of candocuronium led to numerous related neuromuscular blocking agents with short durations of action but also having attendant undesirable cardiovascular effects. The Marshall Group then explored other modifications at the 3 and 16 positions of the androstane nucleus, but the work has not yet yielded an agent worthy of expanded evaluation to clinical testing in this azosteroidal class of neuromuscular blocking agents. References. External links. Neuromuscular plus blocking plus agents at the U.S. National Library of Medicine. Medical subject headings, MESH.